Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 35 search insert position. We're given a sorted array of distinct integers as well as a target value, and we need to return the index if the target is found. If not otherwise, then we're going to return the index where it would be if it were inserted in order. And we have to write an algorithm with O of log n runtime complexity. So in this example, the target is 5 and we return the output 2 because index 2 is where our 5 exists. In this example, our target is 2 and we return 1 because this is where it would exist if it was in the list. And the same for example 3. And then we've got constraints. So the way we can do this, knowing first of all that our list is sorted and we need to do an algorithm in O log n time, well, these are two very big clues because it means that we need to use a binary search approach for this problem. We don't have to, but it would be the most optimal solution as opposed to an O of n time, which would be just iterating through the list in a single pass. So let's code this up using binary search. Let's set our left pointer equal to 0, our right pointer equal to the length of our numbers list, minus 1, and while the 2 pointers are less than or equal to each other, so while they don't cross over, let's get our midpoint. Our midpoint is going to be equal to the sum of the left and right pointers divided by 2. We're going to say if nums mid equals our target, well then we're going to return mid because that's going to be, well, that is where the index of where our target value sits in the list. Otherwise, if our target is greater than nums mid, we're going to set our left pointer equal to mid plus 1. Otherwise, if it's less, then we're going to say right pointer is going to be equal to mid minus 1. But what happens if our while loop finishes? Well, if you think about it, our left boundary is our L pointer is our left boundary of our search range, and before the 2 pointers cross over, L will be equal to where the target value would be if it was in the list. So all we have to do is return our L pointer. Let's run our code. Let's make sure it passes all test cases, because you can never be sure. Amazing, we passed all 66 test cases in a very optimal solution. So of course, time complexity, since it's binary search, is O log n. So I hope you guys found this video useful and helpful, and I'll catch you in the next one.